by doing. So what I am going to do is I will try to explain the principles of operation of the various devices, the measuring instruments and the circuits that I outlined little ago. I will also then demonstrate the working of the working principles by actually performing that part of the theory which we learned, by actually going over to a laboratory table and performing those experiments on a breadboard side by side. This, I believe, will enable you to get greater confidence in the principles and working of electronic devices and circuits, and therefore at a later time you will be able to build different circuits on your own and learn from them. Before we proceed further, it is important to understand how and where the different circuits will be built and tested. We will use what is known as a breadboard for constructing the different circuits and for testing. This is very useful here, as we do not have to solder the different components while we build the circuits. The normal scheme is to take these components and solder them together on what is known as a group board by soldering them. With soldering I mean you will use a lead and then use a soldering iron, which is a hot iron, and then join the different components into various configurations of the circuits. If we do such soldering, then you can imagine the components will have to be cut into different sizes to match the circuit, as well as once you solder, the components may get spoiled. We may not be able to use the components again later on. Whereas in a breadboard, it is very convenient because you are not going to solder the components. You are going to just insert the components or the leads of the components into small tiny holes, which I would show you in a moment, and therefore you don't have to solder and the component need not be cut. So the resistors and the various components can be used repeatedly for different circuits. Let us now see how we can use the breadboard. What is the basic principle of the breadboard? I have shown on the screen a typical breadboard which will be used for building the different circuits. Many of you, I am sure, are familiar with this type of a breadboard perhaps. You can see the breadboard is a plastic board with number of holes on it. There is a pattern of holes. For example, you can see vertically there are 5 holes marked A, B, C, D, E on the screen on one side, and then F, G, H, I, J on the other side. So you have a whole row of such holes on either side with a small cavity in the center, and then you also see on either side, top and bottom, between the two lines, the red and the blue lines, there are a whole range of holes which are running parallel to the length of the rectangle. Now these lines which are running at the extreme ends between the two blue and red lines are called power lines or rail lines. They are generally used for connecting the power supply lines for the various circuits. The other holes which are marked A, B, C, D, E, etc. are basically 5 holes in a node, and they all correspond to one single node. They are, most of the time when you build circuit, you would find you require many points to be connected together. Now here we have 5 holes. That means 5 different components or wires can be connected together to one single point. That is what we mean by the 5 holes node here. How is it done? For knowing this, let us look at the figure that we have on the screen, where you can see, for example, below that holes in the breadboard that I showed, you have a set of clips, metal clips, in the form shown in figure A. This is basically a metal clip which has got very narrow hole at the point where I show, and when you insert a component, for example here in figure B, a resistor is shown. When I insert the resistor inside the clip expands little bit and grips the lead of the resistor at this point. So that is how the connection to the resistance is made at these 2 points, and this clip is actually very long, as it is shown in figure C, which will actually align below the 5 holes that you saw on the breadboard. So by connecting different components through different holes corresponding to the one set of 5 holes, you would find you will be all interconnecting them, because all of them have got individual clips below them which are all connected by a single metal frame. Let us look in some greater detail the scheme of things on a breadboard. Now this is actually a cut view of the breadboard. You can see the 5 clips, 1, 2, 3, 4, 5, which will come under these 5 holes, A, B, C, D, E or whatever, and you also see on the sides, which I call the power supply channel or the rail voltage channel, you would see there is one single metal clip running all the way down for the entire length, and these holes therefore will provide one connection for the power supply. So for example, if I connect this hole or this clip to the plus 5 volts or whatever of a power supply, on this side I connect it to the ground or the minus terminal, then you can see that I can get the 5 volts and the ground from any other point along the length for wiring to my circuit, which is going to be formed between these 2 rows of 5 holes each on either side. I hope you get the picture. Now how do we check? I mentioned all those things, but unless we check that the pattern of wiring or the connections provided below the breadboard or the way I just mentioned to you, we will not be able to understand the building of different circuits. So we have to try and measure or find out whether the connectivity is there in the breadboard as mentioned by me a few minutes ago. How do we check that? For that we have to simply use what is known as a digital multimeter, the DMM, and a couple of wires. You insert, for example, 2 wires which are removed, insulation removed, and insert the metal wires into 2 of the holes between which you want to check whether there is a connectivity or not. There is an electrical continuity, that is what we call. Now choose the resistance mode of the multimeter. So what you are essentially doing is measuring the resistance between the 2 wires you have inserted into the breadboard. If the resistance shown is 0, that obviously means there is no breakage in the circuit, there is continuity or there is a connection below these 2 wires. And if the digital multimeter in the resistance mode reads infinite resistance, that corresponds to open, that means the 2 points are not electrically connected.